All right. Hey, everybody. It's your favorite SQL dude, Taylor, back at you. And I could say your favorite because Tom Fowles will not be joining us this evening. He may be watching, but he won't actually be on the broadcast. So I don't think we have to worry about hurting his feelings here. All right. So we'll just wait for people to tune in here. All right. Looks like we got a couple of people on board now. It's Taylor, your favorite SQL guy. Tom will not be joining us, at least on the video portion of the broadcast here tonight. So I, at least for the day, will be your favorite SQL tutor for the moment. Okay, so we've got a few visitors showing up here. Go ahead and shout out in the comments, if you would, where you're from, if you've joined us here. And I'll go ahead and check on that here too. We've got a couple laptops set up here at the same time. So I'm just pulling that up on my end here. Okay, good. And then also, you can feel free to put in the comments what type of jobs it is that you're looking for in regards to SQL, or if you are looking to learn SQL for a job that you currently have, for some project that you're currently working on. Okay, but it looks like 6 o'clock has rolled around here. Hey, Nava, good to see you again. Hopefully I'm saying that right. And let's go ahead and get started looking at some of these join examples. Specifically, first, we're going to be talking about the difference between the old syntax that people would use for joins, which you still see out there sometimes, and also the new syntax. And then I'm going to take you through 3 examples, one very, very easy and basic, one medium, and one pretty decently hard, large, complex join. Okay, so hopefully by the end of this, you'll feel some extra confidence with joins that you can do them yourself, and also to know the difference between the old and new, and to now know moving forward that you will vow to never use the old syntax ever again. Or at least if you're me and you're displaying your SQL queries around me, that you'll take pity on me and only use the new stuff because it's easier to read. Okay. And just a quick look here at the comments. So we've got Nava from Morgan Hill. Good to see you again. Kaylin from Bay Area. Okay, so 2 people from California. Luis from Northeastern Massachusetts. All right, welcome, Luis. Mark, data analyst and business analyst. I want to master my SQL join queries, linking the relational tables with the keys. Okay, great. We'll talk a little bit about that here, Markham. So good to see you as well. Thanks for commenting. So I'm going to be presenting my screen for the majority of today here. So let me go ahead and get that set up here. Okay, so I'll share my entire screen. Ooh, and it's looking lovely for everybody here. Okay, so go ahead and let me know in the comments. Hey, Fabian, good to see you from Mexico. Very nice. Great to have you here. Let me know if you can see my screen. Can somebody mention in the comments if you can see my screen? John from Atlanta, good to see you. Just want to make sure that I'm not just talking here and people can't actually see anything. You guys see my screen? Somebody go ahead and, okay, great. Luis says yes. Okay, so moving forward then, let me go ahead and make this full screen. So we're here. Let's go ahead and actually come to a different window. Specifically, let's go to SQLprep.com/sandbox. Actually, that's a good link for you all to know about in general, in case you haven't known about in the past, is that you can come here to SQLprep/sandbox, and this will allow you to just go ahead and run your own queries on our different databases, which we have here. Okay, and the ones you often see in our courses and in our daily SQL challenges are your retailer one or your world database. Sequila you'll see occasionally as well. Okay, and so for today here right now, we're going to work with our retailer database as we work through some of these examples. So joins, a basic, and here's a schema, by the way, for that retailer database. And in fact, you can even pull up this page on your end if you want to follow along directly in that way. So with joins, pretty much we're grabbing data from multiple tables at the same time. And there's multiple reasons you could want to do this at the very base level. It's just because you say you want to see the customer name and you want to see their payment amounts. If you're going to do that, then you have to, at least if you're working in this database, you have to go ahead and pull data from both tables at the same time. All right, so if we were to grab that customer name from our customers table, and we run this, then we get a list of all the customer names, and that would just pull from the first table. And then if we wanted to see the payment date and amount, then we would also put that here in our select, payment date, and amount right there. And then we'd want to include that we're pulling from our payments table so that we can see it. Now to do that, there's two ways to do it, okay? So first is this one. You can say from customers, comma, payments, okay? Although you need to have a way to link these two together so that we can match the right payment to the right customer, in which case we'll go ahead and give our tables aliases here, C and then P for payments. Ooh, and Abby is here from Nairobi. Welcome. Oh, that's awesome. Okay, and then we would say where C dot customer number equals P dot customer number. All right, and I'll explain the linking together of the keys here in a second, but this is how you generally do it. We'd say we want to pull from the customers table and the payments table, and we want to match up rows from the customer table where the customer number for that row equals the customer number in the payments table. Okay, so we're only going to see payments from customer 1 matched up with customer information for customer 1. All right, so let's run this here. And there we go. Okay, so now we're seeing the customer name, the payment date, and the amount for each payment that they've made. And of course, we're seeing that there are multiple for various of our customers because they've made multiple payments over time. So this is one way to write this out here. Any of you know if that's the new or the old syntax? Go ahead and comment in the comments there with your guess as to whether this is the new or the old way of writing a join. And it is correct. It still works, whether it's new or not. And but as you're commenting in there, I'll just go ahead and tell you that this is actually the old way of writing SQL joins, to put both tables here, just separated by a comma in the from clause, and then you're indicating the join here in the where clause. And you can have other conditions here too. You could say, and amount is greater than 10,000. I'm not sure if there are any that fit that. Okay, yeah, we do have some that fit it. All right, no, you're right. Yep, it's old. And so you can have multiple conditions here in your where clause, but you have to have this one that is specifying the join between the two tables, customers and payments. Now let's go ahead and contrast that with the new style, which I prefer much more. So instead of putting them both in the join or in the from clause, you're actually going to pull the second table into what you could call a join clause here. Okay, join payments P, and instead of putting this part in the where clause, we're actually going to include it in our join clause, and we say, instead of where, we say on. Okay? So to run through this, we're coming from the customers table, joining the payments table, and instead of where, we're saying on. Customer number from the customer table equals customer number from the payments table. Okay, so this is the new way. And then once again, just so you can have them both on the same page to contrast them, this is the old way. Customer C, comma, payments P, where that equals that. So you can see the difference there. It's not very much. The reason, though, that I prefer the new way, which is here on the top, is because it's a little clearer visually. Since we see this join, we immediately know, okay, we're pulling from multiple tables here. Whereas here in our old method, if you've got a big, long chunk of code for your SQL query, then at first glance might be hard to really see that you're pulling from multiple tables. It also might be hard to see that this is in reference to the join specifically, and it's not just some section of your where clause where you're specifying that the amount is greater than or less than something, or you're specifying that the customer name, that kind of stuff. So it's a lot more straightforward, and I would recommend that you use the new method that uses the join keyword as well as the on keyword to link the two tables together. And that's one way that can help to impress employers as you're going through for interviews. Although you should also be familiar with the old syntax. Sometimes even your potential employers will be using the old syntax, and so you want to be able to run with either one. Okay, so let me know if you have any questions on that, but that is our little introduction here to old versus new syntax. Now let's take a second to go back to what Mark had mentioned in regards to linking the relational tables with the keys. Okay, so with these relational tables, all of them are linked together with keys. That's one of the main criteria that you have in determining that it's properly relational. Okay, so what I mean by key is we've got customer number here in our customers table. Let's go ahead and come back here, and let's just say select star from customers. Okay, so here's all of our customer information. We've got our customer number column here on the far left, and that is our primary key column, meaning that it uniquely identifies each row in our table. Customer 103 is Atelier Graphique, and that is the only customer with customer 103. All right, and then 124 is Many Gifts Distributors Limited, and 124 is going to be the only customer associated with that number. All right, so that is our primary key. Each table will have its own primary key. When you're linking the two together, though, then there needs to be some relationship between the two tables. And you'll be using what are called foreign keys. In the case of customers and payments, it's a little interesting because both of them actually use the customer number column, as you can see here, as the primary key that uniquely identifies them, at least in part. Payments also will use check number in combination with customer number to uniquely identify it, since a customer can have multiple payments. Okay, so let's see here. Let's go ahead and do a join between customers in our orders table, for example. So let's say we want to see the customer name again, and we want to see the order date, and you know what? And then also the order. And yeah, let's just do customer number, customer name, and order date. Okay, so we're going to say customer name and then order date. That'll come from customer C, and then we'll use our new syntax, join orders O, and then we need our on portion of our join clause where we say C.customer number equals O.customer number. Okay, let's run it. There we go. So now we've got our customer names and our order dates. So what's happening here is there is a link between the customers table and our orders table. It's this customer number column. That customer number, it's not the primary key in our orders table because the order number is the primary key. The order number is what uniquely identifies each row in our orders table. The customer number column, though, is there to reference to the customers table. So when we're joining, we can say, hey, we only want to match up the orders for customer 123 with customer 123. Okay, so you've got your primary key, which uniquely identifies each row in a table, and then you have foreign keys like customer number in our orders table, which is the foreign key that links over to the customers table. So go ahead and take a look here at our schema, and you can just sort of guess what is primary key and foreign key. Say, let's look at our products table and our order details table. Okay. So you can take a look at what you think are the primary keys first. So go ahead and think about that in your head. You can even write it in the comments if you want. I'll give you a second to think there. And then we'll also look at what the foreign keys are in this case. Okay, so the primary key in our products table is our product code column. And it's even indicated here by this lovely, beautiful key right there. And then our order details table, the primary key is actually a combination of the order number and the product code. And that goes into an interesting discussion because our products and orders table have a relationship of a many-to-many relationship, and therefore we have to have this order details table to explain some of this data. I won't go into that today. We'll save that for another time. But so we've got these two columns combining together to form the primary key. Now, as for the foreign keys, if you look in our products table, well, there isn't actually a foreign key in relation to the order details table, but there is one in our order details table, and actually that's going to be our product code. Okay, so the product code is referencing the products from our products table. And some of this, I mean, ideally, you're going to be dealing with schemas that have all of this enumerated out very clearly. So you can see what is the primary key, what's the foreign key. Sometimes you're not that lucky. Maybe a lot of times you're not that lucky. But if you don't have that, then you can just go ahead, grab data from these tables, and look at the schemas and just sort of guess what would be the foreign key that would make sense in a relationship between two tables. Okay, and we can see that sometimes, like in this case, the product code is the foreign key and it's part of the primary key as well. All right, so that's a little discussion there. Let me know if you have any questions in regards to primary foreign keys. I can go ahead and address those, and we'll probably take another session down the line to talk about it in more detail. But with that said, let's go ahead and move on to a couple practice problems. Okay, so these will both be here with our retailer database. And I'm going to grab the text for these problems, post them in the comments here on the webinar, and then you guys can go ahead and just follow along that way. Oh, looks like my comment is too long. So let me post it here. So I just posted the first part, and now I just posted the second part as a separate comment. Okay, so corporate wants to see if there's any correlation between customer success and local sales reps. To start, we want you to find which customers work with employees in their home state. So we want to show the customer names and the states of those that apply. Okay, so we want to see two columns, customer names, and also the states of those customers. And specifically, we just want to see customers who work with a sales rep that live or that work in the same state that the customer lives in. All right, so first things first, we want to identify which tables that we're working with here. So we'll come on over here and we'll see that, of course, we need our customers table in order to get our customer name. And then if we want to see the customer state, that also is here in our customers table. But if we want to make sure that it's also the same state as the employee, we're going to have to work with our employees table. And specifically, we need to work with our employees table so we can get to the offices table, that being the offices of the employees, so we can see the state of those offices. Okay, so we'll come down here, and we obviously will need a select statement. Let's build out our from clause, though, and our joins. So we need customers, C, and then we're going to join in our employees table, E, and then we'll also join in our offices table so that we can access the state for our offices. And then we can't forget here that we need to do the on portion of our from here, our join clause. And so we're saying on E dot, and in this case, the foreign key, if you guys can see, is actually sales rep employee number. This one's a little different because it's not actually the same as the primary key name in our employees table. So just be aware that that is possible. Sales rep employee number, and then we'll join offices on, once again, oops, I actually I missed this. So E dot sales rep employee number equals E dot employee number. Just realized another mistake here. Coming from our customer table. Okay, so C dot sales rep employee number equals E dot employee number. And we'll join offices O on O dot office code, which is right here, equals E dot office code. So in this case, office code is the foreign key in our employees table. Okay, so we've got office code equals E dot office code. Just like that, we've gone ahead and linked together these three tables so we can pull results from the combination of the three. So we know that we want our customer name, and then we also want the customer state. So we've got both of those there. Let's just run this as is to get our results, which are there. So we see a list of all of our customers and states that they are based in. Now remember that the question, and Nava, I see you had a question, and I'll get to that in just a second here. Remember that the original challenge here is we want to see customers and their states only for customers who work with an employee from their same state. So in order to do that last part here, we need a where clause. And we want to say where the customer state equals the state of the employee they work with. You might be wondering, well, how do we know that this state is the state of the customer? Because this is just the state of an office, right? And the reason we know is because we've already linked together each customer row with their correlated employee row. So because we said we've got customer signal collectives, and we're going to grab data from that customers table and link it together with data for the employee that is their employee, because it's the employee who has the same employee number as the sales rep employee number from our Signal Collectibles Limited column, which is sales rep employee number. Okay, and then they're linking that to the office. So we're just getting the office for that associated employee. So since we have that together, we can say something like this, and we know that it will be the state of the customer linking to the state of the office of the employee. So now let's run this, and we see that our list gets a good bit shorter, although as you might suspect, it definitely still have customers who work with employees that are based in their same state. Okay, so that's how we do that problem. Let me know if you have any questions on that. Getting to Nava's question, when you're doing the on part, does it matter which table you list first? So that's talking about this guy right here. So it actually doesn't matter. So we ran this, it gave us these results just to test to make sure. We can actually switch this, and we can say on E dot employee number equals C dot sales rep employee number. Run this, and you see that we get the exact same results. So to answer your question, no, it does not matter. And to make it simple, probably use some type of getting some type of habit of either using the first table first or the second table first. Whatever way works fine. The main thing you want to do, though, is to go ahead and enumerate these aliases here, because sometimes you don't actually need these. Like, for example, if we did this without the C and we ran it, we get the same results, and I didn't even put the alias right there. And that's because there is only one sales rep employee number column, and it exists in the customers table. So technically I don't need it, but it's a lot easier for other people coming in to read your code to do so if you enumerate it completely. Just say, you know what, this comes from our C table. C is customers, like that. Okay. So I would encourage you to do it that way, but it doesn't matter which one you actually list first. All right, so that's the first problem that we wanted to go over. So we've got one more that we want to take a look at here for today. And this one's definitely a little more complex and is going to involve more joins. So let me grab the text for this one, and then I will post it in the comments for you to take a look at. Okay, text is pretty long here too. So let me just post it in parts. Okay, there's the first part in the comments now, and here's the second part right there. So in this case, I'm going to read it off now. We want to make sure the company is taking care of top clients. We need to find our most profitable orders that haven't been shipped yet so that we can give those customers extra attention. So we want to find the 5 biggest orders, which when we talk about biggest, we mean the largest subtotal, the largest dollar amount that have not shipped yet. And we want to display in a report the employee name, the customer name, the order number, the order subtotal, and status for those 5 largest subtotals. Okay, it's a bit of a mouthful here, but we'll just gradually work our way through this to get to the right answer. So I'll get rid of everything we have written out here first. And so what we want is we want information about orders that have not been shipped yet. So let's just clarify that a little bit. If we're pulling from our orders table, we've got this column called status here, and that's what we're talking about. So let's select star from orders. And here we go. So these are all the orders. We see this column here called status. Let's find the ones specifically that have not been shipped, where status not equals shipped. And now let's run it. And there we go. Okay, so we've got ones that are resolved, that are canceled, on hold, disputed, in process. Those seem to be the other status types for orders other than shipped. So now that we have that here, just a second here. Yep. Okay, now that we have that here, let's go ahead and see what type of data we want to display. Let's take a look at our schema to figure that out. So we want the first and the last name of the employees that are overseeing these orders. So obviously we're going to need to work with our employees table for that. We also want to see the customer number for the customers who have these non-shipped orders. So that can come from our customers table, although there are other tables that also have customer number, so we'll keep that in mind. We would need the order number for the order that isn't shipped. So that's going to come from our orders table. So for sure, at this point, we're going to need employees and orders, and also customers, since customers is what links employees and orders. And then let's see, we also need the order subtotal. And the subtotal is going to actually be a computed column, a combination of 2 columns. That's going to be our ordered, quantity ordered column from our order details table, multiplied by our price each column. Okay, so we're saying like we ordered 10 widgets, and each one costs $10. So the total subtotal there is 10 times 10, which is $100. Okay, so that's how I figure that out. And then, of course, we also want the status, which is coming from our orders table again, so that we can show that we're working with ones that are specifically not shipped. So we need to link employees, customers, orders, and order details together. Now, one question that might come to mind is, well, is there a particular order that we need to join these tables together? And there are some cases where it matters more so. In this case, it doesn't really matter. So we could start with employees, or we could start with order details. What I would say does generally matter is don't start in the middle. So like if we're combining these 4 tables here, don't start with orders and then do order details and then come backwards and do customers and then do employees. It can be a little confusing, although technically it would still work, as long as you're not doing left or right joins, which we can get into at another time again. But I would start with either employees or order details and then work my way around our lovely little join arc here. So first, let's start with employees, then we'll do customers, then we'll do orders, then we'll do order details. And Bryce has chimed in saying, will this video be uploaded later? Would love to reference it. The answer for you is yes. Yes, it will be. So actually, should be almost, at least I think it's almost immediately after we finish this YouTube live video, that it will be recorded and viewable on YouTube. So you can actually reference the same link that you're watching at right now. You can also reference the video link directly on YouTube to watch it again. Okay, so let's grab from employees, and we'll give it the alias of E. We'll join customers, C, and we'll do it on our employee number once again, is coming from employees. Employee number equals C.sales rep employee number. And the key here with this on portion of our join clause is that one column, or one of these things needs to come from table A, the other one needs to come from table B. Okay, unless you're doing some type of self join. Okay, now we'll join orders O on C dot customer number equals O dot customer number. Okay, so in this case, customer number is a foreign key in the orders table referencing our customers table. And then lastly, we're going to reference up to order details here. And so we see the primary keys marked by the actual key symbol here. And the foreign key in order details that references orders is actually just order number. Okay, so this is another case where the foreign key is also part of the primary key. So we've got OD dot, we'll do O first, O dot order number equals OD dot order number. Okay, so if we selected from that, then we might crash the system because we're grabbing everything all at once, which is a lot of data. But essentially, we should see employee information next to customer information, next to order information, next to order details information. Now, to specify specifically what we want to see here, once again, we want the first name of our employees, and we also want the last name. To make that a little more pretty, formatted nicely, we'll concatenate it by putting a space in between there so that there's a space between the first and last name. We'll give all this an alias. We'll say as employee underscore name. All right, now we also want the customer number. And so to do that, we will see C.customer number, and then we want the order number for these orders. So we can say O.order number. And next we want the order subtotal, which is going to be a combination of our quantity ordered and price each columns. So that's going to be OD.quantity ordered times OD.price each. Okay, and let's just put this in parentheses just to sort of make things a little clearer that there's some computation going on here. And we want to say that's as the order subtotal. And lastly, we want to see the status, which will come from our orders table. Okay, let's run this first, just for all orders. And it might take a second here, and because we're getting a result here for every single order that's ever been made. And there we go. So we see the employee name that transacted the order, the customer number for the customer whose order it is, the order number that's in effect the amount of the order, so $4,080, and we see that that order was shipped. So the last thing we need to do in this case is add a where clause. We're going to say where O.status not equals shipped. Actually, there's one other thing we need to do too. So here are all the orders and subsequent information for all orders that have never been shipped. Okay, last thing we want to do, we just want to see the top 5 of these. So we're going to say select top 5 right there, and then we're going to order by the order subtotal descending. Specifically, we want to see the top 5 in terms of the amount that they ordered. And there we go. Okay, so we've got Leslie Jennings who's looking over an order that's on hold, and we've got one in process disputed, on hold, canceled. So now we have this report we can give to our employer, say, hey, these are 5 orders that we should put some priority on because they're big orders and they haven't been shipped yet. So our customers probably aren't going to be very happy about that. And there's more money to be made. All right, so that's our second example here with joins. We ended up joining 4 tables together, and we got that result. So let me know if you have any questions here about that. If not, I hope you found this helpful here as we went through some of the basics with joins. Last thing I want to mention, oh, now it says, is top 5 a clause? No, top isn't a clause. Top is a keyword that you can use. And you can shift this to whatever order you, or whatever number you want. You can say top 10, top 15, top 20. So it'll just show you however many results you specified. So if you say top 10, it'll just show you 10 rows, the top 10 rows based off of whatever order that you specified. In this case, we went from largest subtotal to smallest subtotal. Okay, so hopefully that answered your question. This is for SQL Server specifically, the syntax with top and then the number. There's other ways to do it too, like in MySQL, you actually will use, you'd write something like limit 10. Yep, exactly, just like you said. And it really depends what you are in. If you're in SQL Server, you use top. If you are using MySQL, then you'll use limit. So I don't believe top works in MySQL. Okay, so there we go. I do want to make one offer to you all here today. Some of you may have this course already, some of you may not, but I want to go ahead and offer you some additional practice through our 20 SQL Joins course. Our 20 SQL Joins course is a course that has, as you might expect, has 20 joins in it. Well, actually has more than 20 joins. It has 20 join challenges in it. It's a practice pack. And so here it is on the inside right here. And we can see here's one of the challenges. And this takes the form just of all of our various challenges. You can see the schema, you can see prior queries, prior attempts that you've made, that is. See the hint, you can see the correct results. You can even see the full answer, which we will quickly scan away from so you don't cheat. And then we just go through and we have 20 different challenges here for you to go through, all of which involve joins, okay? And we also have videos that explain each of these joins as well, where I take you step by step, sort of like how we did our practice problems today. I do that in these videos. So I'll give you access to each of those videos as well so that you can see our mindset as we solve each of these problems, especially if you get stuck. But even if you get it right, you can see and compare the way you thought it through versus the way that we thought it through. Okay, so just sort of scanning through these here a little bit so that you can get an idea of what types of challenges we have here. Some of them are very easy, just joins between a couple tables. Some of them get pretty complex, joins between 4 to 7 tables, maybe even more, and including some other difficult elements as well. If you can confidently solve all the challenges that are in here, then that will be a big chunk of what you might need as far as being ready for an interview for SQL, because joins really are at the center of what most people are looking to see out of potential job applicants, at least ones that are ones that they'd want to hire, right? Okay, so I want to go ahead and make you guys an offer. Normally we sell this course here for $50, but for today, and by today I mean over the next 24 hours, if you purchase this before 8 p.m. Eastern Standard Time tomorrow, then we will go ahead and give you this course for just $10. Okay, so we're discounting it 80%. And I'm showing my face one more time here as we finish up. But go ahead and discounting the course by 80%. So instead of $50, $10, I'm going to go ahead and put the link for you to make that purchase here in the comments. So bear with me just one moment as I grab that here. Once again, this is to our 20 Joins course, offering it to you all for just $10 as long as you purchase it with this code before 8 p.m. Eastern Standard Time tomorrow. Okay, let's see. Oh, that's weird. It's not letting me add the link here. Let me try again. And just a second. There we go. Okay, so I just put the link in there. You might need to put www before that, although I think that will work just as is. So that's the link if you want to go ahead and take advantage of that and you haven't already gotten access to our 20 Joins course. So 20 challenges leading you through. Each one has joins. We have explainer videos that explain the whole process of solving each of those problems too. And so I'll give you a good chance for more practice. And if you buy it before 8 p.m. tomorrow, then it'll only cost you $10. Okay, so let me know if you have any other questions in regards to joins. I'd love to answer them. And let us know if you have any suggestions for future webinars that we'll be doing. As you can tell now, for several weeks, we've been doing one every week. And so we want to go ahead and continue that run here. So give us a shout out with what you'd like us to cover. And with that said, that's about it for today. Once again, the link is in the YouTube comments. That's the link to go ahead and get our 20 Joins course for just $10, as long as you purchase before 8 p.m. Eastern Standard Time tomorrow. And that has 20 challenges in it, all of which include you having to make joins. And we have helper videos, which you go ahead and we'll run you through each of the challenges on their own. All right. So great seeing you all here. Keep on practicing. Practicing is far and away. Practicing actually writing out SQL queries is far and away the best way to prepare for your on-the-job tasks as well as for these job interviews. All right. We'll see you next time.